right. So we are live. Cool. All right. I have created the remaining last 10 steps for this policy training project, and I'm gonna start them
Mm-hmm.
sequentially. And yeah, let's focus on that. And we'll start our day with our synthetic data generation. I basically understand. Oh, you have not turned on the sport, by the way.
Do reload.
I'm doing shift reload.
No, my bad. It should be
Oh,
on.
now it's on. Yes. Yeah, yeah. Okay, so and we were at step three, and we have almost completed the step three because we were trying to understand the. Oh, this is my conversation at the gym today.
Mm-hmm.
I was trying to understand tensors.
Nice.
So
Ten,
I get the whole picture now.
tensor.
So yeah, let me just initiate that task and I'll bring my coffee and we can resume. Start on step one. And also I'm gonna skip sparring tomorrow so we can go for a little long.
Why, bro? Skipping sparring, bro. Go for it.
Bro, my neck is fucked up from last week, so I don't wanna risk it.
Makes sense. Neck is. So you're not doing icing and everything that you have to.
I'm doing like I did that gua sha thing. Like I have that gua sha, like that metal one.
Uh-huh.
And I was doing it in steam and sauna today.
Mm-hmm.
I don't have that ice pack.
Hmm.
I am gonna box tomorrow, but I'm just gonna hit the bag. I'm not gonna spar, so I'm gonna wake up at my own time.
Hmm.
Donald J. Trump. Today I concluded a deal to substantially lower the price of ground beef for working American families. As everyone knows, under President Biden, beef prices soared at their fastest rate, and the American beef herd fell to its smallest size in modern history as we work to rebuild this herd and help our ranchers for the next 90 days. The United States will allow up to 300,000 metric tons of product for ground beef to be imported with no out of quota tariff. We have a commitment that this beef will be sold at 25% below the current market price. This deal will reduce the prices for Americans while giving space. I don't know, bro.
अबे चूत मरी की बात है.
Bro, we are on live.
Oh, fuck, bro. I forgot.
We are live, brother. Keep that
Go
in
Donald
mind.
Trump, brother. Go Donald Trump. Inflation that is going on and gas prices, and that is affecting the economy most because like the whole US economy runs on fuel and everything. Like even
Mhm.
if you are trying to transport one thing from another, like Walmart and other goods, that is gonna bring your cost of goods and other necessities, groceries and everything up as well. So
Nice.
it won't matter if he's trying to bring or
Be
if
back.
the beef prices.
Yeah. All right, let's continue. Okay, so I'll let that happen. And we can get started with this shit again. Let me turn on the timer for 45 minutes. Is it Bethany? Where the fuck the function? All right. So now we did it till here. Experiment D eval, and we know what the evals mean now as well. So we basically so dummy image is like a test image. This
Mhm.
three means RGB numbers. This means image height. This means image width. And then the image tensor is given in the target and the label. And losses are calculated by running dummy image and dummy target together in the model function. And then we print the losses. And right now the losses are like this, and then model.eval torch no grad out is equal to model torch dot rand image height image width device is equal to device. So we have ran the model on this partic- particular dummy image, and print keys is equal to list out 0 keys. Okay, let's ask what's gonna be the output of this.
Just print it, bro. What? Why are you gonna ask? Just print out. And it's probably gonna be a tensor, multi-dimensional tensor that will have labels and boxes both, as we know. See,
Boxes.
so it's a dictionary.
Yeah, it's a dictionary. And then tensor. So these are the boxes. And these are the keys. And what the fuck? These are the keys. These are the boxes. Torch dot size. Blah blah blah. Let me just keep this for a moment. Oh shit. Um, what was the fuck command? Command. Oh shit.
It's command slash.
Yes, yes. I forgot for a second. Hmm. What happens if I do dot keys? How does it know what keys are?
Do dot keys? Why would dot keys work? Dot keys is not a it's not a dictionary. It's a tensor dictionary. So you have to do out and then one. Like, okay, copy that format that you have on the boxes, and you cannot do dot keys. Look on the second line of the print statement and copy that.
Mm, and then list.
Yeah, now do it. No, it's not necessary to do list. It's fine. It's fine. There you go. List will be.
Dict keys. Where? How does it know these are the keys? How is it getting that information? Are we giving it somewhere?
Yes, brother. That is the output that it's expecting from the model architecture. It's a
Like
build.
we have added that code over here somewhere
It's
in
in
the
faster
config.
RCNN. It's inside the faster RCNN library.
I don't think it's in the
Go
wait.
down, go up, go into the build model. It's gonna be in the build model. If it's not in the build model, then it's inside that. Go up, go up, go into build model, bro. Go into build model.
Okay.
You won't find labels. I'm telling you, dude. You won't find labels. That it's inside the
Yeah,
library.
build model. Yeah.
Look at it. Do you see? Do you see? Are we defining it somewhere? No, because it's inside the faster RCNN.
Okay.
So faster RCNN is directly doing it.
Mm-hmm. Print key list out. Hmm. Hmm. Prepare the data set. Okay, so this is done. एंड कुछ भी हो सकता है, जीरो भी मॉडल भी अनट्रेंड है, रैंडम नॉइस पर जो भी लगे वही दे रहा है। क्यों ये इम्पोर्टेंट है? सेम मॉडल सेम कॉल, बिल्कुल अलग आउटपुट, फर्क सिर्फ इतना, मॉडल डॉट ट्रेन, मॉडल इमेजेस टारगेट्स, डिक्ट ऑफ फोर लॉसेस, मॉडल डॉट eval, मॉडल इमेजेस लिस्ट, डिक्ट बॉक्स लेबल स्कोर्स और एक छुपा हुआ बोनस eval मोड में एनएमएस नॉन मैक्स ऑपरेशन ऑलरेडी लग चुका है टाओ। ओके ओके ओके। इस सेल में ये है एंकर जन। ओके एंकर जेन। This is the code, bro. One anchor size per FPN, P2, P5, pool 5 levels.
Mm-hmm.
FPN level, एक size और size का 3 मतलब मॉडल इसके आसपास शीट बॉक्सेस प्रपोज कर सकते हैं. Oh, so these are the sizes that the box can use to describe the object,
Mm-hmm.
or like the model can use to describe the box.
Mm-hmm. Dude, I think these are the sizes for. Yeah, then why do we have aspect ratio?
Aspect ratios.
Yeah.
हर एफपीएन लेवल के लिए एक साइज और हर साइज के लिए 3 एस्पेक्ट रेशियोज. So this is size and this is aspect ratio. And this into 5 means these sizes. कभी प्रपोज होगी ही नहीं चाहे हम धारे. So the total dimension of a image is going to be size into aspect ratio. So if it is 32 into 0.5, then it's going to be 16px.
Mm-hmm.
That's what it means. That's why they have done it like that.
Mm.
ये एक स्ट्रक्चरल लिमिट है. ट्रेनिंग से ठीक होने वाली चीज नहीं, इसलिए 4.3 का सैनिटी चेक बॉक्स वेट हाइट तक मीडियन मैक्स प्रिंट करता है. एक असली डायग्नोस्टिक आराम से उड़ाया हमारे इसलिए ग्रेटर सीन में बहुत है. अगर कभी तुम्हारे असली रेप्लिकेटर सीन मूवमेंट बहुत छोटे निकले, मान लो 15x 2 साइजेस, तो साइजेस में 16 ऐड करना होगा. ResNet 18 इमेज नेट पर पहले से ट्रेन ये देखना. द एफपीएन आरपीएन रोल हेड ये स्क्रैच से इनिशियलाइज होता है, इन्हें कुछ नहीं करना होता, इसलिए स्टेप 5 ग्रेड वार्म अप आता है. शुरुआत में अनट्रेन्ड हेड बहुत बड़े वे का ग्रेडियंट में आता है. बिना वार्म के वो ग्रेडियंट बैकबोन तक पहुंच कर सकती नॉलेज को खराब कर सकते हैं, जिसके लिए हमने ये बैकबोन चुना है. वो पहले कुछ जनरेशंस में लर्निंग रेट को धीरे धीरे बढ़ाता है ताकि नेट थोड़ा सेटल हो जाए। डाउनलोड हैंग SSL error, code error, no code no damage, image net weights, download internet check कराओ। All right, we are moving to our main step, which is generating the data set, synthetic data set. किटी उसे किटी फॉर्मेट में कन्वर्ट करेंगे, सैनिटी चेक करेंगे, डेटा सेट पर डेटा राउटर बनवाएंगे और ग्राउंड बॉक्सेस आंखों से वेरीफाई करेंगे और वहाँ हम स्टेप 1 वाला टारगेट क्लास साइलेंट फीचर फेलियर्स को जानबूझ ट्रिगर करके देखें कि वो कैसा दिखता है। Fuck my neck, bro. All right, step 4. We add step 4 finally. Oh, fuck. Main step of this fucking tutorial. Prepare the data set.
Yes.
Oh, we have a lot of viewers today. 6 viewers. Damn. Two hops, replicator output, kitty, and then data set. Kitty is kept as the on-disk intermediate because it is human inspectable and is what the rest of the ecosystem, including Tau, expects. So the converted data stays portable. Expected replicator, basic writer layout under data raw. Okay, so replicator output is, I'm guessing, the synthetic data, which is going to be converted into Kitty and then going to be stored as a data set. And Kitty is kept as the on-disk intermediate because it is human inspectable and it is what the rest of the ecosystem, including Tau, expects. So converted data stays portable. Valid. Okay, and now इस स्टेप में क्या सीखोगे? ये ट्यूटोरियल का सबसे बड़ा और सबसे जरूरी स्टेप है। ज्यादातर डिटेक्शन प्रोजेक्ट्स यही मरते हैं, मॉडल में नहीं, डेटा में। ओके, इसलिए यहाँ हम हर इंटरमीडिएट आउटपुट को खोल कर देखेंगे सिर्फ सेल चलाकर आगे नहीं बढ़ेंगे। ओमनिवर्स रेप्लिकेटर का बेसिक राइटर आउटपुट इस किस शेप में आता है और उसके बिना भी पाइपलाइन कैसे एक्सरसाइज करनी है? ओके, रेप्लिकेटर इज किटी कन्वर्जन में एग्जैक्टली क्या होता है? रीसाइज, स्केल, फिल्टर। हम्म रेप्लिकेटर किटी कन्वर्जन में एग्जैक्टली क्या होता है? किटी लेबल फॉर्मेट्स के 15 कॉलम्स और उनमें से सिर्फ 5 ही क्यों यूज होते हैं? टारगेट क्लास का साइलेंट फेलियर लाइव ट्रिगर करके देखना, डेटा सेट और डेटा लॉर्डर, और डिटेक्शन में कस्टम कोलेट एफएन क्यों मजबूरी है? टाइम लगेगा। ओके, so we need to run all the cells again. Okay, 4.1 replicator kitty converter PIL import image. Kitty label columns type truncated occluded alpha x1 y1 x2 y2 hw l x y z r w r y. Yeah, bro. Some days YouTube just decides randomly to promote our videos, and there is a lot of people watching.
What I'm telling you, bro.
Random. Okay, so raw output को inspect करो notebook cell 4.1 converter define. Oh, so this is just 4.1. Okay, so def कोई replicator scene wired नहीं है और data raw खाली है. Is it data raw toy scene 0? Oh, did you already run it?
No, bro, I have not. I think it's the old one. Oh yeah. I think we did ran it. Yeah. We did ran it for testing purposes. That how does it perform? I think when I committed the code, I wanted to test it out if it works or how it works on this new architecture.
Mm. Mm-hmm. Terminal में VNV activated. Python scripts generate toy data set out data raw N96. How many did they generate? Yes, 96. JSON. What is this JSON? Hmm. Three images.
Noise. It's gonna be noise.
But the synthetic data is useless, is it?
So, dude, now we have a box. That's why I'm trying to take a look. There is a box on over here.
I don't know how that came, but what is labels? Palette jack. Okay.
So it's because the
Uh,
coordinate or the mapping in that image where that box lies. If you
mm,
compare it with the image, the like frame 00020, and then we will see.
okay, let's source dot. What is it? Dot venv.
Yeah, I guess so. Yeah,
Bin activate.
yeah.
Yeah, and then Python script. I think let's delete. I will delete this.
Delete it.
Let's see if that generates it again.
Yeah, it generated.
Yes.
Garage, 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 garage.
Wrote 96 toy frames, data raw toy scene, Q 950, 916 50. 916 to 540 स्क्रिप्ट डिफॉल्ट 960 के ऊपर दिखता है जबकि डॉट की इमेज विड्थ हाइट 1280 ये जानबूझकर मिसमैच है ताकि कन्वर्टर का रीसाइज रीस्केल पाथ एक्चुअली चले नो ऑप ना बन जाए अगर दोनों सेम होते तो तुम कभी टेस्ट ही नहीं कर पाते कि बॉक्स कोऑर्डिनेट सही स्केल हो रहे हैं या नहीं आई सी ओके अगर तुम्हें कभी असली रेप्लिकेटर आउटपुट डीबग करना पड़े तो ये फॉर्मेट समझना काम आएगा। ये डेटा Oh, every scene has three files of its own. Nice, I get it now. So there is a .npy file, there is a JSON file, and there is a PNG file.
Mm-hmm.
Okay, so this is what the PNG looks like right now. Raw data there, scene 0, ARR, np dot upload box, blah blah blah, allow pickle, true. Data type, add data type. User semantic ID, I4, Xmin, F4, Ymin, F. Oh, Xmin, Ymin, Xmax, Ymax, occlusion ratio, field semantic ID, Xmin, Ymin, Xmax, Ymax, occlusion ratio, row 0 is array 0. Okay. Okay, 916 to 540. This is the image size. RGB is mode, I'm guessing. Whew. Okay, I get it. This is a structured numpy array.
Mm-hmm.
Normal array, structured numpy array. Is a numpy array where each element isn't just a single number, it's a record made of multiple named fields, possibly with different data types. Think of it like a lightweight table or numpy version of a list of struct rows rather than the usual numpy array where each element isn't just a single number, it is a record made of multiple named fields, possibly with different data types. Oh, no, no. Every array is the same data type. Every element is the same data type. Int. Structured array. Data is equal to np dot array. Alice 25 5.5. Bob 36.1. D type. Name Newton. Age I4. Height F1. Here each element of data is row with 3 named fields. A string U10, a Unicode string, max 10 characters, a 4-byte integer, a 4-byte float. Accessing fields works like column section selection. Here, each element of data is a row with 3 named fields. Name string U10, Unicode string max 10 chars, 4-byte integer, 4-byte float. Accessing fields works like column selection. What is it trying to say? I'm not able to understand. Here, each element of data is a row with 3 named fields: name, age. Okay. NP array is Alice this, Bob this. And then data type is defined. What is this? Do you know what a structured data and an NP array is? Structured and NumPy array.
No, I do not recall it, but it says as it says over here. Over here, I think it creates labels of the tensors that we will have in our array. So if we go down, it's defining that, I guess. So
So
data.
it's saying data is equal to np dot array, Alice, Bob, and then 25, 5.5, 36.1. And then over here it has a third element in that, not a third element, but like a,
Dude, it's the type of data.
oh, it's like another, okay, D type is name and U10,
So it's like, okay, what are
and
you trying
age
to?
I4, height F4.
It's saying that what are you trying to say inside?
Here each element of data is a row with 3 named fields: name, age, and height.
Something DJ.
What up, bro?
Yeah.
How was the party?
Nah, I don't think so. What's up, man?
What's up, bro?
I don't think so. I think it's just wasted. No, she's not. Her friend was throwing me over the side. Feel free to take a breather.
Mm-hmm.
I'm gonna get some.
A 4-byte float. A string name. A string. U10 Unicode string. Max 10 characters. Name, age. Oh, so this is. Oh, okay. So data D type is like something that's defining each of these elements over here. So name is this.
Dude, if you take
Age
it down, you will
is
get it.
this.
If you go down, you will get it what it is doing over there.
Okay. Accessing fields works like common selection, so data and name. So only, and then they can return this array of Alice and Bob. And the D type would be U10 and then data age. Yes, I get it now. Okay. Why it exists when it's used? It lets you store heterogeneous tabular data in a single NumPy array while still getting NumPy speed and memory efficiency. It's stored as a contiguous block of memory, not Python objects like list of dicts would be. It's essentially a precursor to pandas.data frame. Pandas is built on top of NumPy. Bro, I did a lot of projects in pandas and NumPy, but I don't recall shit.
I only recall one statement, DF.
Your pants are right? Yeah. Somewhere.
What is DF?
I remember seeing it. It's right over there.
What DF?
Import data frame to DF.
Oh, data frame.
DF dot read underscore
Yeah.
basically that thing.
I see. I think the YouTube algorithm has rejected us now. 0 views.
Yeah, look how crazy. Good thing we didn't. The Reese's looks like it's fun tonight, but look how crazy that is. Yeah. Yeah.
Okay. Essentially a precursor to pandas.data frame. Oh, it's that does say it over here, data frame.
Oh, that's
Pandas built on top of NumPy and structured arrays are one of the underlying mechanisms for representing labeled mixed type of tabular data before pandas existed. Lets you store heterogeneous tabular data in single NumPy array while still getting NumPy speed and memory efficiency. It's stored as contiguous block of memory, not Python objects like list of bits could be. It's essentially a precursor to pandas.data frame.
being able to hear.
Pandas is built on top of NumPy. Okay.
I realized I could hear a second.
Alright. It's time for me to hit the road.
Yeah, well, stay safe out there. As you can see by the person who nearly hit you will be relieving. That was so stupid. Alright. Over here, take that, go down. Near the gate that we left at.
Yeah.
Take that.
Alright, well, I'll see you maybe next weekend.
Yeah, I'll see you soon.
Alright, have a good one.
See you, man.
I think it's high time, bro, that you start wearing AirPods and
I don't. It won't happen. It won't happen that often. So we good.
mm,
But it starts happening like yeah. Then I will definitely get it. No, we good.
mm, oh, bro, this synthetic data and like machine learning has fucking opened my mind.
My God. Oh, fuck, bro. Mhm.
Our 45-minute mark has completed as well.
Okay, yeah,
That was quick.
that's
But
how.
no, we need to like we should dive a little deeper in this, bro. Otherwise, we won't complete it.
Why won't we complete it, dude? Every 45 minutes we are progressing, dude. Take a look at the last 45 minutes.
Brother,
Progress a
the
lot.
last 7 days we have come from 1 to 4 till
So what,
here,
bro? So
and
what?
the
It takes
fucking
time.
first and second and third were just setting up the environment
So,
and
dude, okay,
configuration.
if you, dude, it's like, what, you cannot do anything about it, bro. If you want to understand each and everything, it's gonna take time.
I'm saying let's invest a little more time today in this
Yeah.
Do you mind if
because
I water the like?
Oh yeah, yeah, sure. You can take a chill one as well. It's
Thank
from
you.
the freezer if you want.
Thank you, man.
Yeah, I got you.
yeah. I'll say let's just complete step 4 at
Okay,
least. Yeah.
okay.
We are on step 4.1. No, 4.2 actually.
Mm-hmm.
So, okay, so that's what it says that it's we have basically this dot .npy is a structured numpy.
Mm-hmm.
Oh, now I get it. Semantic ID I4 xmin f4 and then labels. Oh, this is D type over here. Oh, okay.
Mm-hmm.
So this is what it means. D type
Yes.
over here.
Data type. Like I think it helps you. It helps you to basically pick up specific things from your NP array.
Hmm.
Basically, getting like what are the names that exist in that array? What are the ages values that exist in that array? What
Hmm.
are the height values that exist in that array? So you can
Yeah.
basically pick up individual tensors.
Yeah. To
Uh,
call it separately and perform calculation on
yeah,
them.
like you can do no distribution. You can take an average of all the height. Like it's more like you're playing with the data. That's where an NP array kicks in. So if you
क्यों ये समझना जरूरी है ये स्ट्रक्चर्ड नंबर एरे है नॉर्मल एरे नहीं हर रो के नेम्ड फील्ड्स होते हैं रेप्लिकेटर्स बेसिक राइटर यही लिखता है दो चीजों को नोट करो सिमेंटिक आईडी एक नंबर है नाम नहीं नाम अलग जेसॉन फाइल में है ओके सिमेंटिक आईडी इज अ नंबर ओके डॉट एनपीवाई बॉक्सेस के लिए डॉट जेसॉन आईडी क्लास मैपिंग के लिए ऑक्लूजन रेशियो ऑब्जेक्ट कितना ढका हुआ है ओके ऑक्लूजन रेशियो 0 पूरा दिख रहा है 1 पूरा छुपा है ये फिल्टर करने के लिए मिलता है रियल रेप्लिकेटर सीन्स में ये का बहुत काम का होता है ओके ऑक्लूजन रेशियो वेयर इज ऑक्लूजन रेशियो ओके नोटबुक ओके सेल 4.1 कन्वर्टर डिफाइन करो तो क्या करना है 4.1 रेप्लिकेटर किटी कन्वर्टर वाला सेल चलाओ ये क्या दिखेगा कन्वर्टर डिफाइंड बस ये सेल सिर्फ फंक्शन डिफाइन करता है चलता नहीं ओके सो इट्स आस्किंग अस टू रन दिस नाउ converter defined ओके हर बॉक्स पर इस ऑर्डर में सिमेंटिक आईडी क्लास नेम लेबल्स जेसन से अगर क्लास टारगेट क्लास इज नॉट इक्वल टू टारगेट क्लास ड्रॉप कोऑर्डिनेट को स्केल करो I'll be back 1 second.
Mhm.
Oh god. Oh god. Salamakis. So do you know what Uber is doing? Where the fuck did you go? Bro, do you know what Uber is doing?
Yeah. There you
They
go.
are monitoring your battery life, like battery percentage on your phone to like raise prices if you are trying to book. Like their AI is basically monitoring your battery percentage so that they can charge you more if you're in a hurry to get home or
Yeah, bro,
something.
that's what Uber does all the time. Like, even Uber also does the same. Uber and Lyft have a thing where if you open a cab,
Mm-hmm.
click on it and go try to book it, right? And they're like, hey, I'm changing my mind. I'm gonna use another app. And then you go on to another app and see the same thing. And you come back to the app again. They're gonna raise the price by $2 or $3.
Mm-hmm.
And the more number of times you do that, they're gonna increase like $1 or $2 almost on every visit until it reaches a max peak point. Cause that's what I saw at the airport when I was in LA.
Mm-hmm.
The point where I got charged like crazy stuff. That's what
Mm-hmm.
they did. Like they increase the price like every freaking time. Like it would cost it. So I asked the Uber driver, hey, how much are they paying you? And they were paying him like 20 bucks. That's it.
Mm-hmm.
And the cab costed like 40 bucks. The
Mm-hmm.
cab costed like 60 bucks, and the rest of the money goes into the pocket of Uber. Like 40 bucks goes directly to Uber, and the cab driver is only getting paid $20 out of that 60 bucks.
Mm-hmm.
Alright, bro. Like I think we should. Where are we at? What are we doing?
Yeah, bro. 1 second. All right, come on. Let's get it, boy. Yeah, boy. Fast as fuck, boy. Fast as fuck, boy. All right. Yeah. Function क्या करता है हर बॉक्स पे? Okay, so let's understand this code. Raw replicator files. Okay, so this is what this code does basically.
Mm-hmm.
This so it has the raw replicator files, which are these files that we have over here. We generated via synthetic data generation,
Mm-hmm.
right? Generate toy dataset.py, and what it is doing is taking those files and then parse structured array. So boxes from npy. Semantic ID class name, अगर class not equal to target, then drop coordinates को scale करो, frames के अंदर clamp करो, ठीक करो. Negative यहाँ अगर occlusion है तो drop. अगर width या height is smaller than or equal to 0, drop. अगर width या height is smaller than 8 pixels, then drop. And then बचा kitty line लिखो. Alright, kitty files. Okay. So boxes from npy, parse structured array, class filter, keep only target class boxes, resize box clips to bound, scale and clamp, quality filter, occlusion 0, area, min size. What is
Clamp. What
uh,
clamp does?
hmm?
You already know what clamp does, I guess.
That min max thing?
Yeah.
But that is torch.clamp. I don't think that's the same thing over here.
No, no.
Oh yeah, no. It might be the same.
It's
Yes,
gonna be the same
yes.
thing, dude. There's nothing else apart from it.
It is basically defining a range in which we need the values.
Yeah.
Okay, and then okay, so def boxes from numpy, return semantic ID, occlusion from replicator bbox file, array np.load, str np path, allow pickle true, out names dot r dot d types dot names. Okay, so so you can store the names in r dot d type dot names directly from the structured numpy
Mm-hmm.
for row in r. Okay, so now we are iterating over np load this. If names in structured array, the normal case sid is equal to int row semantic id x1 y1 x2 y2 float row k for k in xmin ymin xmax ymax awk occ float row occlusion ratio if occlusion ratio in names else 0 else plain. Okay, sid. Okay, boxes from npy. ओके, और इमेज को 1 2 पर सी से मिन बॉक्स पिक्सल इज 8 आउटपुट पिक्सल्स में नापा जाता है, सोर्स में नहीं. मतलब जब तुम अपस्केल कर रहे हो 962.182.1280 तो सोर्स का 6 पिक्सल का बॉक्स आउटपुट में 8 पिक्सल बन जाएगा और बच जाएगा, जबकि उसमें कोई असली सिग्नल नहीं है. ये थ्रेशोल्ड अपने आउटपुट रेजोल्यूशन के हिसाब से सेट करना, सोर्स के हिसाब से नहीं. नोटबुक 4 सेल 4.2 कन्वर्जन चलाओ. क्या करना है? 4.2 रन द कन्वर्जन. बस सेल चलाओ, क्या दिखेगा? ओके वेट. Convert replicator to kitty is creating class filter. Keep only target class box, scale and clamp. 6 stages, 1 dummy frame for flowing top to bottom. Here's what's happening at each stage. Raw replicator files. For every frame, ISAC-SIM replicator drops 3 files and RGB. For every frame, ISAC-SIM replicator drops 3 files and RGB. Image, a numpy structured numpy file with a bounding box with bounding boxes and JSON mapping semantic IDs to class names. Boxes from npy loads that npy file. It's written to handle two possible formats: structured numpy array named fields like semantic ID, xmin, xmax, which is the normal replicator case, or plain n into 5 n into 6 array as a fallback. Either way, it returns a clean list of class ID x1, y1, x2, y2 occlusion tuples. Class filter, the dataset only cares about one object class, target class example car. Any box whose semantic ID maps to a different class name gets dropped.
What happened with this inventing box?
Close the NPY file. It's written handle two possible formats: a structured numpy array, name fields like semantic ID, xmin, xmax, which is the normal replicator case, or plain N5, N6 array as fallback. Either way, it returns a clean list of class ID x1, y1, x2, y2 occlusion. On tuples, class filter, the dataset only cares about one object class, target class example. Okay, target class. But where is it doing the conversion? Sorry, where is it doing the filtering? Agar class boxes are scaled to image size, clamped to the frame, then dropped if they are more than max occlusion. Occluded degenerate, zero area after clamping, or smaller than min box px. On either side, min box px is measured in output pixels.
Boxes are scaled to image size, clamped to the frame, and then dropped if they are more than max. Occlusion occluded degenerate zero area after clamping or smaller than min max. Min box on either side.
Min box is measured in output pixels either. Let's check what's happening with our
What? Oh,
policy.
oh, I think it did something. It's straightening. But are you applying in Amazon?
What?
Are you applying in Amazon?
Oh,
Like Amazon has a couple of robotics position.
oh yeah.
Yeah, I just did apply to one. Like I did not, my agent did, and I just got a notification.
I will check it out, brother.
Mm, mm. What's our policy saying over here?
1 second. Okay. Fucking. Oh, okay. So basically, we were trying to do this. I'll show you. Implement the 5 out of distribution suites in evaluate policy, uncomment each block configs evaluation suits YAML. Replace not implemented error nor branch with real per suite randomization. Post friction mass overrides applied at reset per suite's own episode count and seed list and confirm each suit randomization actually lands on the sim state. The same way the smoke test error resolve task config check confirmed for viewer overrides back in policy B camera work. Don't trust the override path silently. So what did it do? Training uses hard init points and hard init or noise, so those suits ranges are strictly narrower than what policy is already trained on. The suit would measure negative generalization gap. I don't understand it, bro. Can you read this and try to take a look what they are trying to do?
Found both under policy guardrail the docs path are related to the directory. Let me understand how the environment config knows these suits need to drive. Before writing the code, I checked the specified suite ranges across what nominal runs produce. Post shift has specified its outer distribution.
What did you get?
Mm. So what I understood was that we try to figure out what is the value of our post shift based on a nominal distribution that we have. And when we looked into it, our post shift values were basically inside the nominal values that we're supposed to be in. That's what it said in that thing. That's it. I think it's looking for it's we what we did was we looked into our values and figured out, okay, is this under a specified normalized distribution? Like which percentile is it given falling in? Like is it in the top one percentile, or is it in the 39th percentile, or in the middle range? I think that's what it did. Uh,
Oh, this is just fucking. Okay, so basically we have just modified our evals
mm,
by adding new conditions. Check the settings weren't already too easy. Two of them were the written down numbers wrong about the whole were actually gentler than the robots trained on, so the test would have made them look more robust when they are. You pick the fix instead of moving a hole, we lie in the robot. About where the hole is, its eyes are wrong. The touch can save it, make the code proves the settings actually took effect rather than setting a value and assuming it worked. And the script now reads the number back out of the simulator after startup and refuses to run if it doesn't match what was asked for. Hmm. Okay, so now we are going to run the all 12 existing trained policies
Mm-hmm.
through all 5 suits, same launch pattern. Okay. Commit this and start step 2. It takes me at least मुझे ये चीजें समझने में at least decade तो चाहिए. The global critic has commented on our thing, on our chat.
What?
There's a guy in the chat
Mm-hmm.
who was saying मुझे ये चीजें समझने के लिए एक decade चाहिए. Same here, brother.
No, bro. Just pure 90 days of consistency, and you will get it. As Andre Karpathy said, 10,000 hours of machine learning. What is this saying? Okay.
Oh, why the fuck my neck is hurting after like 5 days of sparring, bro? What the
Dude,
fuck?
because you are doing pull-ups. Pull-ups put strain on your neck as well. And just do freaking icing. Or if you are in that pain, okay, I would suggest you to get a cryoderm. Like you can look up on Amazon. It's like a $15 spray, and it's gonna take care of your pain and everything.
What is it called? Cryoderm.
Yeah, cryoderm. Yeah. The one, two, three, fifth, second one in the second row.
This one.
Yeah.
Cold spray.
But if you use that, do not use any icing or anything. Like it's instant. It has menthol and everything. And dude, like this spray is crazy.
Oh, I think Conor McGregor also endorsed something like this same thing.
Oh yeah, dude, cryotherapy. Oh, let me see how much is in it in India.
Mm. Bro, I got this salt and stone. This is
Mm-hmm.
pure marketing. This is so shit. This is
You
so
paid
shit.
fucking $32 for that? Oh,
Yeah, bro, once.
holy moly!
And then I switched back to native.
Oh, a native. Oh, like I'm using what I'm using right now. I'm using Old Spice. Yeah, I got it from Amazon.
No, native is good. $9 for a big bottle.
Mm.
Yeah, bro, this fucking. I even bought this salt and stone. I'll show you what the fuck is this. It's so shitty, bro. I got all this salt and stone, like this cream,
Mm-hmm.
Hinoki.
Mm.
Body lotion is $50. It's so expensive. Black rose and oud. This is like if you want to waste money, you can buy all this shit. I started buying this when I first got my job. I was like, now I am the shit. So now I can buy all this. But soon after, I got back to my basics.
Mm.
Tier armies. Oh, well, never mind. All right, it's doing it now. So let's get back to where we were over here.
Mm-hmm.
Or do you want to do lead code first
Dude,
now?
let's do lead
Um,
code. Yeah, let's do lead code. Otherwise,
but I think we should come back to this before finishing the stream.
we'll see. Let's complete lead code.
All right, let me find the question for the day. And we'll do the same thing. I'll take like 20-25 minutes. I'll start the timer
Mm-hmm.
and you can solve it in the meanwhile as well
Mm-hmm.
in 25 minutes.
Dude, like,
And then,
okay, so the thing is, I know as soon as I see the question, I know if I'm able to solve it in that amount of time or not. Like, it's instantaneous. That's the thing. So I would give up in literally less than 5 minutes if I know that okay, I know this is a question that I won't be able to solve at all because I haven't seen anything about it.
but
I
at least you try to do it on your own machine.
Dude,
Like,
no, I know, but like the typical hack with lead code is that thing only. If you're not able to get the logic in less than 5 minutes or 10 minutes, then you are already you like you need to the logic should be in your mind. That's what I'm saying. Not I'm not saying that it should be on the screen. But it should be in
excuse
your
me.
mind. Okay, this should be the approach for that. Like if you're doing brute force, then that's different thing completely. Like for the yesterday's question, I was like, okay, dude, this is something that is gonna be copy paste. Oh,
Number of
yeah,
islands.
this is a good question as well.
I think I have done this
Same
question
logic,
before, but
same logic, same logic as
okay.
manually. Not that difficult though.
But I will take my time in
Yes.
doing it. Don't say anything. Like, don't tell me the solution right now. I'll start a timer.
Okay. Started.
Let me start the timer. How many minutes? 25? Yo,
Yeah, like 25 minutes tops. You should have returned the pseudo code, like at least the base code that you wrote as
Okay.
yesterday within 25 minutes, like everything.
Okay.
At least the
Three, two, one, start. Let's see. Hmm. Given an m cross n 2D binary grid, okay, and let me also open. Oh, what the fuck? Where the fuck? Okay. Okay. Given an m cross n 2D binary grid, which represents a map of ones land and zeros water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent okay. So, an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water and return the number of islands. Okay. So, over here would be one, two, which represents a map of one's land and an island is surrounded by water. Oh, yes, one. Okay. Output one. Okay, and this is one and two and three. Yes, got it. Got the question. Okay, now. Okay, one. No, drawing oranges, directions. M length of grid and length of grid. Direction 01101 as well. Okay, QDQM. Counter zero. Fresh. For R in range M and C in range N. Grad R comma C is 1. Q dot append RC. Yes. Else. Uh, grad RC is 0. Hmm, remove this. And this is going to be over here. While Q. R comma C is equal to NR and C is equal to I plus go in that direction. Oh, got it. If So we are storing all the indexes. One, right, and then R comma C pop left. We don't need to append it again, so this is wrong. Hmm. What? Oh shit. Hmm. The fuck did I miss? What am I doing wrong? The fuck? The fuck is it not taking anything in the queue? Is it because I am not initializing it?
I will tell you a small bug. You are so look at the matrix that you created and look at what value you are providing, checking it. Look at the matrix that you have on your left hand side. Look like what does that matrix have? What is the data type?
This one.
Yeah. What is the data type of the elements in each array?
Int. Int.
Are you sure?
Or is it string because of quotes?
Yes. So yeah, you need to check for string and your value. So your for loop is never gonna check inside it. Your
Hmm.
RC is never gonna check.
Oh, now it's working. Out of range? What does out of range mean over here? Out of range?
Oh, you have out of bound because you have not created that if loop, if condition where you are checking if nr lies between a certain value. It should nr should always be between 0 and less than m. If it is greater than m or less than 0, it's gonna break, and that's what happening. You have not put that if 0 less
I
than.
removed that. Oh, okay. Because I thought we don't need it over
No,
here.
dude, we need we that is a critical point in BFS. That's what defines if your search goes out of bound or not in any point.
Oh, supply.
Nice. What's the time?
Yeah, it just ended.
Nice.
25 minutes.
There, bro. I was able to do it. Lead code high strikes.
Lead code medium, bro, not hard.
Yeah, bro. I know that's fine, bro. Medium, like if it is taking me less than 20 to 25 minutes, then I'm good. Like I'm not out. I'm just out of practice, but just just enough time.
Hmm. If zero and R, what am I missing here?
And you're missing and brother. How are you gonna check? You're
Oh
missing one
shit,
and.
and
You're missing one and. Nine, you got
Nine.
9 islands, bro. Because you're checking for each and every grid zero. So the thing is, if you read the question again, an island is surrounded by water and is
I
found.
know. I understood the question. I'm just not able. So okay, look at my logic. You need logic here to run until it's zero here, and then exits to return the count of increase the count of islands by one, so that we don't. Oh, I think I know what am I missing. Okay, wait.
But why are you increase? So I will tell you what where your logic is flawed right now. So over here, you're checking whenever you are getting water, you are increasing the number of islands, and that is incorrect, right? And you're also missing if you have already visited that node. What happens in that scenario,
Yeah,
right?
exactly. That is the logic I want to build. That I'm not able to
Okay,
build.
so like what you can do is, do you want me to guide you or what do you want to do?
Okay, wait. Let me try it, and then if I don't, I'm not able to do it. I'll ask
Hmm.
1 second. Grid. No. It's gonna be Q brought up and what was it? NRNC. Let's see.
It's gonna break. You're still not visiting, dude. You're still not visiting. Like the problem is you're not visiting your nodes. And
Okay, tell me now. What am I doing wrong?
first of all, like you have to understand our BFS approach. So what do you
Mhm.
understand by the question, right? Like I want you to.
Right now, what I understand is over here. Okay, this is gonna be one island. Oh my bad. This is gonna be the island.
Mhm.
So we are gonna return one.
Right. That's it.
Yeah.
So now,
Hmm.
okay. So in
And
your
I'll explain my approach as well.
okay, yeah.
So what I'm trying to do over here is I'm trying to first create a queue
Mm-hmm.
in which I'm gonna store the index values of all the one
Yeah.
elements, right?
Yeah.
Okay.
Uh-huh.
And then basically what I'm gonna do is uh, run a while loop
Mm-hmm.
in on this queue
Mm-hmm.
to basically find
Mm-hmm.
the in four directions, these
Mm-hmm.
four directions.
Mm-hmm.
So for instance, I start with this one,
Mm-hmm.
right? So I'm over here.
Mm-hmm.
I go in all four directions, right? And I cannot go over here, so it's naturally zero, zero, whatever.
Mm-hmm.
But if I'm going in this direction
Mm-hmm.
and I find, okay, this is equal to, oh, I think this should be one, I guess. Let me try this.
No, dude, like your logic is flawed completely. Like that's why, like it won't work. Like there are a couple of changes that we have to do in the code. So
Okay, so yeah,
run it.
I'm just confused over here. I think this part I'm fine,
Okay. So
and I get what the question is also, but
okay,
I'm just
so
fucked up
I
over
will
here.
okay, so I will walk you through what your code does and at what point your code is wrong. So
Uh-huh.
from line 15 to 20, right?
Mm-hmm.
You are appending the queue. Like you are
Yeah,
checking basically, hey, at
if
every
the
point,
value is one or not.
every value is one or not. So as soon as you find that hey, there is a value one, then we can denote
Yeah,
it
I
as a
append it
power,
in the queue.
right? So what we can do is on line 18, we can
Mm-hmm.
add island plus equal to one because at this point we already know that there is an island,
Mm-hmm.
right? Plus equal to one. Now
Yeah.
we have to initiate one more variable that we will call as visited, and it will be a set. So on line 14 you can type visited equal to set. Right now, what will this visited do is whenever we are visiting any node, it's gonna mark it as visited so that we do not visit it again. This is where your
Mm-hmm.
memory limit will be preserved, right?
Yeah, bro, this is what I was thinking. I was thinking of creating another queue
Yeah.
to store the visited
But,
one.
but we won't
Okay.
use queue, we will just use a set. Now on line 18, what we will do is we will add a new check. That is gonna be if grid r comma c equal to 1 and not n and bracket r comma c
Oh, R comma C.
bracket of not n visited. So what this will help us to do is that hey, if we have already visited the
Like
node,
this.
yes, like this, right? And now on line 20,
Mm-hmm.
we will press enter and we will add the RC inside the visited. So we will, since it's a set, we will use
Mm-hmm.
visited dot add
Oh, okay.
bracket
Mm-hmm.
RC.
Mm-hmm.
Now we will remove the else if because we do not give a fuck where like how many water we find, how many
Mm-hmm.
number of elements we find
And
over.
also queue append this.
No, no, no. We need that. We need that. We need
Okay.
that. Right now, we will remove the. We will put the while queue under 22. Under like in do shift tab until you go inside the while queue. Like we need to bring the queue inside the for loop or BFS inside the for loop.
Oh, like this one.
Yes.
It is
Except islands. Except islands. Except returning islands.
okay. This is under the first for loop.
No, no. We need to bring it in the like inside both the for loops. Like in under q dot append.
Oh,
Do not move return islands.
I know, I know.
Tab.
Okay.
Again tab. Again one
Mhm.
more time.
One more,
Yeah, one more time. I will show you. Yeah, go one more time. Yeah. Okay.
bro. I think this is too much.
No, no, it's not too much. I will show you. Okay. So if you look on your left on your graph that we have on the matrix. So now what this logic will do is so it's gonna first if you look at it. So first we will add 0 comma 0 in our queue, right?
Mm-hmm.
And once we have 0 comma q 0 comma 0, it's in a visited node, right?
Mm-hmm.
Now we will go into the queue. Now since our queue is not empty, our logic will work.
Mm-hmm.
Now as soon as
Mm-hmm.
we are inside the queue, you are also missing. Why are we doing for underscore in range length of queue right now?
To basically iterate over the number of indexes that are one.
Okay, yeah. That so right now since we are inside the for loop, we won't need that. We can delete that,
Okay.
right? We do not need that part now, and we will correct our indentation again,
Yeah.
right? Do shift tab. Now what's happening over here is as soon as we get our 0 comma 0 index in, we are gonna check the neighbors. Hey, do you have a one? right? So as soon as you are inside this, you're gonna check, hey, let's go and explore, do a BFS and look for ones. If we have
When you say BFS, what is exactly you're saying BFS?
BFS is search, so when you're doing
No, over here in code, what is BFS?
while queue, from while queue, like line
Oh, from
24,
while
yeah,
queue. Okay.
that's where your
Okay.
BFS starts, right? So now your BFS will start and you will pop 0, comma 0 index, and you will start
Yeah. In
exploring.
RC.
Yeah, and you will start exploring in all the other directions, right?
Mm-hmm.
Now, once you have started exploring in the other directions, you will know that, hey, do they have one? If they have one, then we will progress and we will append that into the queue. But you are not adding right now the visited. So what we will do is, we also need to make sure that whatever node we are visiting around the node that is in the queue right now, that we have just popped, it is not visited by our system already, because if we move to any other node, right, it's still gonna visit that node when we're trying to reach it over there.
What can you just
So if you look
simplify
at,
this?
if you go
Which code line are you talking about?
line 28.
Yeah, what are you saying?
So we need to add, like, at the end, yeah, add not and visited, like the same line that we did, but for nr comma nc at the end, at the end.
Like two and conditions.
Yeah, like three. There are more than three. That's in, yeah, not nr comma nc bracket,
Mm-hmm.
a small bracket. It should be small bracket.
Oh, for set. Okay. And R, comma, and C.
Not in visited. And
Mm-hmm.
we will do enter and we will add. If it's not in visited, then we will do visited dot add, so that we do
Yep.
not.
Yep.
Yeah.
Look, he forgot it.
Mm-hmm.
Like put bracket, like you have to put that nr comma nc, put bracket again, and then copy paste it should be tuple. That nr comma nc should be tuple, so you have to put another bracket onto it,
Oh.
right? And then we will remove the else island plus equal to 1, right? And yeah, I think if you run the code right now, it's gonna work. Okay, you have not defined island. Oh, it's islands, I guess. Oh, over there on line 19, you need to add a
Mm.
uh,
Bro.
visitor dot add. Oh, again, tuple is not over there. You have to add tuple.
Mm.
Uh, there we go. Okay. Now, what we did over here is, earlier what you were trying to do was, in your older the code that you wrote was, okay, if you add, let's increase the size of our xcali draw so we can understand much better on what we did. So yeah, let's add 0, comma 0 in our queue. Yeah, let's add 0, comma 0 in our queue, right? And now we will just copy the matrix that you have above. Yeah, copy the matrix and put it below the queue so that we can understand it.
Oh, like this.
Yeah, yeah, right. So now we have our 0, comma 0 in our queue, right?
Mm-hmm.
That is added. So we are at the first position, right? And once our code goes onto the line 24, right? When our
Yeah.
code goes onto the line 24, it's gonna check, hey,
Mm-hmm.
what do we have in the queue? We have this in the queue. Now,
Yeah.
when we are inside that block 24 to 30, what it will do is, it's gonna check its neighbors. It's gonna check its neighbors and say, hey, what do we got over here? And it's gonna look, hey, we have one, and they are not yet visited. right? So we can also
Mm-hmm.
create another set, like you can create another, like if you want to, set where you can add 0 comma 0 as well, so that we make
Mm-hmm.
that like you can,
Set is also similar to this,
yeah,
or
similar to that. Yeah, it's also an array, so you can put it as a stack or something, but it's gonna be, and you're gonna add 0 comma 0 into this as well.
mm-hmm.
But now we will add 0 comma 1 as well, since we have visited it as well. 0 comma 1, and then 1 comma 0, right? Since these are the two nodes that we have already visited.
Mm-hmm.
So now what will happen is, if you go back onto the queue, so we will
Yeah.
update our first element in our queue to 0 comma 1. First element, you have to pop out the first element. You haven't popped out the first element yet. So either you can put a cross on it so that it becomes
Mm-hmm.
for us to that, hey, we have popped it out.
Yeah.
Now it's gonna go to 0 comma 1, right?
Mm-hmm.
And it's gonna do a complete exploration from 0 comma 1 again, right? Since, so when once it's at 0 comma 1, it's gonna go and take a look in the back. So again, we are still inside our while queue, right?
Mm-hmm.
Now it's gonna take a look in the front. It's gonna take a look at 0 comma 2, right? It's gonna take a look at 0 comma 2, and it's gonna add 0 comma 2 inside our set again.
Oh, like when we do it in the while queue loop,
Yes, yes,
and it's gonna take a look at this one,
yes.
right?
It's gonna take a
And
look
then
at
it's
that.
gonna add this to this
Yes.
set.
And then it's gonna add that into the queue as well.
So this should not be 1 comma 0. It should be, oh, okay, okay, okay.
That's from the older one. That's the other one.
Older one.
Yeah,
Okay, so it's gonna add this,
yeah,
and it's also gonna add this,
yeah,
which is gonna be
yeah.
what is 0 1
It's
1
gonna
comma
be
1.
1 comma 1, right? It's gonna add that as
Yeah,
well. It's gonna add that
0
in the queue as
0 comma 2 and 1 comma 1.
yeah. It's gonna add that in the queue as well. So you have to make sure
Yeah,
that you are adding it into the queue as well. Since,
like both of them,
yes,
or
both,
just,
yes, both of them, because they were
but
not visited by us earlier.
okay. So in the first pass, I think this one also would have been added to, what is it?
Queue.
0 1 and
Yeah, yeah,
0.
yeah, yeah.
So
It's
this
gonna
is
be
gonna be 0 1 comma 0.
yes, 1 comma 0, right?
So
But
that is also gonna be, and then when we visited this, these two are going to be added in the set
and
and
also,
the queue,
right,
also the
Q, Q,
queue,
yeah,
which are going to be 0 comma 2
yeah,
and 1 comma 1.
yes. Now,
And then
now, we are,
similarly, when we are doing this,
yeah,
now we are going to visit 1 comma 0, this one.
yes,
And now again, because this we have already visited
we
this,
are gonna
we are
skip
not
it.
gonna,
Yeah, we
yeah, we're
are,
gonna skip it.
yes,
But because we have not visited this, this is going to be getting added in
yes,
0 comma, what is it, 2 comma 0 over
yes,
here, and also over here in
yes,
the set,
yes,
right?
yes.
Oh,
Now,
now I get it.
now
Yeah.
there's the important thing. If you go back,
Okay.
now you have to put island equal to 1 on the top. Put island, like put a, like, do I equal to 1. We will denote it as 1. So
Mm-hmm.
we are right now. What happened was, so since we started from over here, we knew that this is an
Mm-hmm.
island, right? Now, until we explore each and every neighboring node, and we are not able to find a 0, we won't stop,
Uh-huh.
right? As soon as we find a 0, this while
Mm-hmm.
will get emptied out, right? And then we are gonna use our for loop that is above on line 16 and 17 to iterate
Where are we emptying the queue if it is 0?
at 25th line 25th.
Like, no, this is just, we are just taking out RC from the
Yeah,
list to
that's the queue.
evaluate it.
That's the queue, right? You're continuously popping it out,
Yeah,
right?
yeah, but like, okay, now, let's say, this is also fed into this and this, and this is also fed into this,
Yes.
right? And then now,
Zero won't be.
when we are visiting one of this,
Yes.
like we have hit a deadline,
Yes.
like we has visited this and this, but it's all zero,
Yes.
and the queue has finished.
Yes.
Like queue has completely, like we have popped
Exhausted. Yeah.
queue,
Q is completely exhausted.
exhausted.
Yes.
Yeah. Then and yeah, what will happen then after
Then
that?
what will happen is this block will end, and the for loop will iterate to the next loop, right? The for loop will choose the next element that is gonna be in the RC.
Which for loop? This one.
Yeah, that for loop 16 to 21. Yeah, 16, like this for loop 16 to 21, the block
Yeah.
we have. It's gonna check. Now it's gonna go to the different for loop. So now what it will do? It's gonna take,
Oh,
hey,
that is why while is inside if.
yes.
Okay.
So what this defines
So I
is,
think I should do this. Yeah.
yeah. So what this defines is, as soon as we know that in the initial for loop, what we are trying to do is, as soon as we know that, hey, we have found out that the value over here is 1, we are going to increment the island plus 1. But if you are not
Mhm.
able to find any element that has 1 again, the island won't be incremented, because we
Mhm.
would have already visited all the neighboring nodes that is adjacent to all the islands, and that have 1, and that will be already in our visited set, right? That's why on line 18 we are checking if RC is not in set. If we have not visited the value inside when we are doing the BFS, then only we will go and check. Like for example, let's say the end 0 we have, right? The 0 in the last block, that won't be visited at all at any point in our first iteration, but at some point it will be visited by our for loop, and the for loop will check,
Mhm.
"Hey, is that value 1? It's not, so islands will be skipped." So that's why right now only we have a single island, right?
Mhm.
So at any point in our first BFS search, if you are not able to find any other island that is adjacent, right, it's not going to increment. But okay, let's say our search when we started from our first node ended, and we are again iterating.
Okay. Answer one thing. If what do you say? Oh, what the fuck? Um,
What?
let's say this is one, right?
Mm-hmm.
So now this is we have two islands,
Yes,
this
now
one
you have
and
two
this one.
islands, because once your BFS has exhausted, it's gonna go back.
Yeah. So BFS has exhausted where which okay, make me
Line
highlight the
22nd
code.
to line 28. We are doing the BFS.
Line 22nd to line 28. Okay.
Yes,
Yeah.
you got it.
While Q.
You got it. Like,
1 second.
okay, I'll be back. I'm gonna take it out.
Yeah.
Okay.
Yeah, 1 second. I should fucking ask for.
What?
Bro, no, my flight timing changed.
For SF?
No,
India.
India,
Yeah, same thing
fuck.
happened with me, bro. That's why, like, make sure that you do not have that the gap that you have. Do you have a direct flight or it's a connecting?
Connected.
Okay, yeah, make sure that the time gap is substantial between your layover. Or if the time gap is not enough, just ask them to rebook it completely.
No, wait.
Right now, what I would say, the prices for premium economy is crazy hard. Like it's like 3 or 4 grand.
Nice. I have premium economy. Oh, oh, okay, okay. My flight timings when I'm coming from there have changed, so it's fine. And the timing has changed by 10-15 minutes. Party every day. That tonight's gonna be a good night.
So you got the logic.
Yeah, I got it.
Yeah. Since we are only counting that how many islands we got, so it won't matter that how many number of zeros we have. We only have to check for what what is the number of adjacent ones we got, and are they grouped in all together. And the complexity is gonna be O m of n again.
Wrong answer, brother.
Is it? Are you sure? What is the complexity? Let me just make sure. It should be O m of n. M cross n.
No, like the test case is failed. Something is wrong with the
Which
logic.
which test case field?
Look at the
Oh,
screen,
oh
bro.
yeah, yeah. There might be something that we might have left some edge cases. So 47, 58. Okay. I haven't ran it on like submit. Since
Bro, run it on submit, then only the answer would be right?
dude, okay,
Otherwise,
wait.
it is not correct.
So we were just doing mock, right? So I haven't clicked on submit. I just ran the first two edge cases to test it run.
Submit it, bro. Then only you can say that
Dude,
it is
mine
correct.
is submitted. Yeah, I got 49 on 49. Okay, there's some mistake in your code then. Yeah, it passed for me.
And is it the same code or is it a different code?
Let me. I think it's the same code. Let me just verify. R, comma C, not in visited, island plus one. Appending I comma j. You are doing the q as well. You have the directions.
I haven't added, I think, the edge cases.
Dude, I also haven't added that. Okay, wait. Where is it? M is correct. Directions are also correct. Islands are also correct. Visited is also correct. We don't need water. For I in range, I did, and then n, and then 1, and then we did visited, and then we added r comma c, and then we went with q, and then r comma c pop left, j in direction. Why the fuck are we playing C? Let me see, is there a bug that is because of which my test cases are passing? Try submitting again.
No, 42 out of 49.
What is the difference you are getting? Wait.
Bro, look at the last for loop. Look at your for loop.
Yeah, I'm looking at it only. Like it's
Copy and send me your code.
identical, not and visited. But wait, I need to figure out before that. Like that's where we went wrong. Append, we are appending.
Just send me your code, bro. I'll compare it over here.
Yeah, let's do it. Yeah, I'm gonna send it. There you go. Send it. Q, DQ, island, YJ, R plus L, C plus G, and R and C.
What has happened to fucking Apple, bro? It's so shit.
Yeah, comment out yours, I guess. Yeah. Run it. Awesome. Yeah, so just
Let me. L plus Z. Okay, I think I didn't do this.
what? Dude, you did that.
I plus R, J plus C.
Oh, I know where you was getting fucked up, bro. Okay, I know. Dude, you do not have distinct variables. You are only doing okay, wait, but do you have but no. You have distinct variables.
And C.
You are doing R J R plus oh I know, go up, go up, go up, go up, go up.
NC,
Oh dude,
NRNC,
I think you did this part wrong, I guess. No, but that's correct. I plus wait. I plus R and J plus C. Go. Oh, I know. Go up again. Go up. Go up. Yeah, more up. More up. More up. Okay. So you have RC getting used 2 times, and that's causing that confusion. You need to rename your variables. Change it to something else. Yeah, because we are using the same variables in for loop as well. Yeah, do LG.
But I don't think it should be the one.
Dude, it causes, dude. I know it causes an issue for some scenarios. Like we do not know what are the edge cases, right? That's why. Like when you do BFS, it's gonna crash it. That's why you're failing. If you do submit now, it should work. There you go. Because like R or C value was incorrect at some point. That's a bug in the code. Because that's why we have to name our variables distinctively. Otherwise, we will have these kind of issues.
Is there a program to check the O of N, like complexity?
No, dude, that's
Time
something that
complexity.
we have to. If you click on analysis, it's gonna give you. That's something that they will ask us, hey, what is the complexity? And COM cross N, as I told you.
Hmm. But yeah, I was able to come close to the solution today
Yeah, but
a little bit.
yeah, that's fine. That's fine. Like that, I knew that you would have gotten closer to it, but this is something you would have to think all the time. That okay, why, at what point we will have memory issues, right? And that's what they're going to test when we are doing lead code. That okay, why are we not using? What happens when we are revisiting the node, right? Since we will be revisiting the same node again and again, how can we avoid it? And to avoid it, we have to use set, and the property of a set is that it cannot have duplicates. So even though if any other elements tries to add more into it, sorry, any
Mm-hmm.
other BFS search tries to add more values into our visited, we will only have unique values instead of duplicates, so that our visited queue is not populated, like not polluted. Populated, I'm saying, what the fuck? Not
Mm.
polluted out. So, but yeah, there we go. This was again a easy peasy 25 minutes timer. There we go.
Mm.
Getting closer. But
Getting
the most
closer.
important thing is our BFS algorithm that we have like thoroughly understood now, and the
Yeah.
variations.
Mm.
That's the most important thing over here. But this BFS algorithm is gonna be used in every search or every matrix question that requires a search.
Mm-hmm.
And I think that the CS50 did taught this, but not in like, I would say, hands-on manner. But yeah, the CS50 has also this algorithm.
Yeah, I might have to revisit CS50.
Yeah. But that's how BFS works. And then in DFS, we are basically doing recursion.
Mm-hmm.
It's going to be the same algorithm for DFS.
Does BFS Python? Q Frontier first in first. Oh. Oh. No, you and I. So I can burn. DFS. Damn, bro. Okay, what do you want to do?
I think yeah,
You want to take a look at
we can end the stream if we want, but worthless.
how weird is sweep to find magnitude? Ah.
Bro, lead code those days. Fuck. That's why I have started to apply for, like, that's why I'm gonna start applying in Amazon and Microsoft since we are doing LeetCode as well. So I got no fear. I got no freaking fear. And we should call in our angel investor once for discussion of the stocks and everything.
Call him right now. You
No,
can do it right now.
2:30. I don't think he will be awake.
Message him. I'll message him.
Yeah, message him.
थोड़ी यार उठा के ले. So लग रहा है. I think he's asleep.
Tiger is sleeping in the cave. Tiger is asleep.
Tiger.
Dude, just replace Tiger with something else and then he will get it. Oh, is he? Or is it you?
It's me.
Yes, brother. My dad will keep sending me the Cloud Code master web seminar and everything. And I'm like,
He doesn't know, bro, that you're the master.
yeah, like I have spent so much money on Cloud Code that I know Cloud Code in and out. Listen,
Look at that sticker, bro. Insane.
what the fuck, bro? What the fuck?
Okay, wait, I'll end the stream, bro. Oh, Jose Mourinho is back, guys. Yes, he is.
Oh, Jose Mourinho is back?
Real Madrid manager.
Oh, okay.
Abhishek is in the chat.
What's up, bro? What's up? I was going to say the word.